All right, guys, we have talked about function notation and we graphed some exponentials and some linear functions. Now we want to talk about what truly makes a function a function. So earlier we saw the graph of y equals f of x is the set of all solutions for that function f. We also found that when f of x equals g of x, the functions f and g, which are just two separate equations basically, share a common solution, and on the graph they intersect at that point. We learned that it defines a function and properties of a function, but before we can define what a function is, we have to talk about something called a relation. A relation, this would be notes. A relation is a relationship between two sets of data, right? It's what they have in common. If you pair any two sets of data, you create a relation between those sets. For example, you could define the relationship between the neighbors on your block and the cars that they drive if you wanted to. Neighbor A drives a Honda Civic, right? Make and model, whatever. You could also define a relation as, on my block, if there's a Honda Civic, it's driven by, person A and person B or whatever. A function, though, is a special type of relationship which each input, in other words, each x value, only maps to one specific y value or one specific output. That's a particular type of function. So a function is a special type of relation, and a relation is just comparing two types of data. So comparing x's and y's if you're thinking about math. Okay, so take a look at the two down here at the bottom. These are a good example of what we're talking about. So the first relation has a domain, which is your x values, and the range, which is your y values. Okay, another way to say that is input and output, right? You've done that before. That was back in middle school. We did some of that. So in this first example, we have 5 separate inputs. And those 5 separate inputs each go to a specific output. In other words, A only goes to car 1. B only goes to car 2. C only goes to car 1. D only goes to car 2. And E only goes to car 3. It's okay that different domains, right, like A and C are both going to car 1. That's fine. That's still a function. So this one is a function. Each input can only go to one output. Okay, now let's look at relation 2. This is just basically flipping it, right? But I have this car 1, right, that's driven by person A and person C. If we go that way and compare that data that way, that is not a function because you have an input, car 1, going to 2 separate outputs. That is not okay. So multiple inputs can go to the same output, but one input cannot go to 2 separate outputs. Okay, this is basically me talking about the example yesterday where Bobby and Joe can both be born in March, right? Bobby and Joe can both be born in March, right? We'll say this is March instead of car 1. That's fine. But what you can't say is that Bobby was born in March and July. You can't have that input going to 2 separate outputs. That's always the kind of example that I use to try and keep up and remember this. All right, so this is just going through it. Make sure you pause and read this paragraph right here. Okay, it talks about domain and range and what those are, and that is extremely important. And down here, we're talking about one way to test and see if it's a function is to use the vertical line test. So to actually go and look at that vertical line test, here we go. You have a graph. Here's your relation, right? The circle represents the relation, and we want to see is it a function. So we do a vertical line test. Now it says do it -2, so that's what we'll do. But really, you can do it anywhere that passes through the circle, right? So there's my vertical line. It crosses here and it crosses here. This fails the vertical line test, which means it is not a function. Okay, we have this input of -2 that has 2 outputs. right? Fails the vertical line test. So that's the easy way if you're given a graph. Check these two. Fails the vertical line test, crosses twice. Passes the vertical line test. Anywhere you draw a vertical line, it will only cross this function one time. So this one is a function, and this one is not a function. All right? Key concepts. Make sure you read these. These are super important. I'm not going to read them all to you. You are old enough to read for yourself. Pause the video as you need to and look at them. Okay? They're all extremely, extremely important. Key concepts for this lesson. All right, example 1 is the relation of function. Use a mapping diagram to determine your answer. All right, so it says use a mapping diagram. The mapping is going to be when you set up your inputs and your outputs and you draw arrows. Okay, so this is your x's, your y's. All right, so I have -2, -1, 0, 1, 2, and 3. And over here, I have 4, 1. You can normally they put them in order. We won't worry so much about that right now. 0, and then a 1 again, then a 4 again, and then a 9. All right, so I had -2 going to 4. I had -1 going to 1. I have 0 going to 0. I have 1 going to 1, and 2 going to 4, 3 going to 9. Do any of those x's that we just had right here, do any of those repeat? Right? Do they go to 2 separate y values? And the answer is no, they don't. What you actually can do, what you probably should do, is instead of putting these last 2 right here, okay, if you see this on a quiz or a test, what you'll most likely see is this. They won't have the 1 or the 4 written twice. Instead, what they'll do, 1 goes to 1, so they'll draw an arrow of that, and then 2 goes to 4, so they'll do that. In other words, they'll draw multiple arrows going to the same y value, multiple arrows going to the same one. Okay, and again, that's fine as long as you don't have multiple lines leaving from the same x. All right, let's see if we can fit in one more example at our time here. Is this a function? Again, use your mapping. So we got 4, 1, 0, 1 again, so I'm not going to rewrite it. 4 again, I'm not going to rewrite that, and 9. Then I have a secondary one where we have -5, -3, 0, 1, 5, 3. All right, so what I have here is I have 4 goes to -5, then I have 1 goes to -3, I have 0 goes to 0, then I have 1 goes to 1. All right, I already had 1, so 1 goes to 1. Then I have 4, oh, I already have 4, goes to 5, and then I had 9 going to 3. So, is that a problem? Yes. This 4 and this 1 cannot go to multiple outputs. You can't have an x going to multiple y's. So this would be not a function. Okay, we're going to look at a few more examples here in just a second.